Hey guys, today we're going to finish off notes 3.7, tangent lines and normal lines. Yesterday we discovered in class how to find the equation of a tangent line of a function at a point. We discovered the calculus would do that. We did these. I even broke it down into a kind of a 4-step method that generally works. Again, if you need to review that, feel free to look back at the Zoom recording from yesterday. Today we're going to talk about how to write the equation of a normal line. A normal line, like what does that even mean? Well, normal line, like a tangent line, it still is a line that goes through the point on the curve, but this time instead of being parallel to the slope, it's perpendicular to the tangent line. Okay, so here's a picture of one. Right here. On a circle, I kind of mentioned that if you take a basketball and lay a wooden board over it, this being the board, the blue, then you have a tangent line because it touches the basketball at exactly one location, and generally the board is going to equal the slope of wherever it hits that basketball. It's going to match the slope. The normal line is perpendicular to that. It shoots out of the curve at a 90-degree angle. So it is perpendicular to the tangent line. Now, what does perpendicular mean? If you remember, it was probably math 2, maybe math 1. Perpendicular. Two lines that are perpendicular have opposite reciprocal slopes. Okay, we're going to see what that means pretty quick. Remember that, opposite reciprocal. You got to remember both those words. So, this example, write an equation for the normal line to this curve, f of x at x equals -1. Well, that's connected to the problem we did yesterday. The first example we did was the exact same problem, except it was the equation of a tangent line. So we're going to use yesterday's information, in fact, yesterday's graph as well. So yesterday's graph, that's the carbon copy of it. I just added the normal line to it. That's in green. The normal line, again, is perpendicular. So yesterday we found in this problem the tangent slope was -2. We did that by, of course, taking the derivative. I'm not going to redo it. You can go back, take the derivative, and plug in -1, right? That was 2x, and then you plug in -2, you get -2. Sorry, you plug in -1, you get -2. That was the slope of the tangent line. Now, if the tangent slope is -2, then the normal line slope is what? Well, we said the normal line is perpendicular, and I've said perpendicular means opposite reciprocal. So, take the -2 and find the opposite reciprocal of it. Well, this is like -2/1. If it's negative, and the opposite would be positive, and the reciprocal means flip the fraction. So the slope of the normal line is +1/2. That is the opposite reciprocal to -2. And let's look at the picture real fast. It looks like, remember let's use green. The tangent line went down 2/1, so it was -2, right? The normal line actually does kind of look like it goes up 1 and over 2. The slope here would be 1/2. So it makes sense. Perpendicular lines have opposite reciprocal slopes. Well, you found the slope. Good. Now you know the normal line slope. That's going to go right in here for m. But what point do we use? Well, I mean, it's still asking you x equals -1. So I can literally take the point that I used here, the -1, 3, or you could find it again if you want, but why reinvent the wheel? Sorry, here I am. To find the point, again, we learned that you just plug the -1, the x, into the original function. So f of -1. So x is -1, and the y, when you plug it in, -1 squared is 1, plus 2 is, again, just 3. There you go. Oops. You have a point, and you have a slope. That is all you need for point-slope form. So our final answer looks like this. Y minus, let's see, the y coordinate is 3, equals the slope is 1/2. Remember, it's not the slope of the tangent line. This is the equation of the normal line. Times x plus 1. And that is all. You can leave it like that. You could change it to slope-intercept form if you'd like, but hopefully you see where everything's going. The slope, as usual, goes right there. The -1, right there. The 3, there's the y coordinate, went right there. Okay, that is it. That is your answer. That's exactly how you do the normal line slope. Now, this one was a little bit easier because we had a lot of information from the example we did yesterday. Let's do one from scratch. In fact, let's do one where now we have to find the normal line and the tangent line equation for the following function at the given value of x. Ooh, okay. This is a tougher function. It's not just a polynomial. We have a rational function. But that's okay. Because at this stage in the game, you have a variety of tools in your toolbox for finding derivative. It's not just power rule. For instance, this one, you can use the quotient rule if you want. It's clearly and obviously a quotient. It's got a numerator and a denominator. Use quotient rule. I've already told you in class that I am very lazy. I try to avoid quotient rule at any cost. So I'm going to split this into two functions, only because it's got one denominator. So I know I can just split it. In fact, there's my split right there. It turns into that. If 2x is the denominator, then both of those are just fractions over 2x. I could almost use power rule right now. But why don't I simplify a little bit? 3 over 2 is 3 over 2. X squared over x cancels out. You just have 3 over 2 times x. I can use power rule on this pretty easy now. Now this one, 4 over 2 is 2. And the x is in the denominator. But I'm just going to bring it up and call it x to the negative 1. Again, so I can use power rule nice and easy. Look, I avoided quotient rule. My rewrite is done. Now I can actually take the derivative. Remember, I have not done that yet. Delete. Now I took the derivative. Right? The derivative of 3 halves x is just 3 halves. The derivative of 2x to the negative 1, well, multiply the negative 1 times the 2. That gets you positive 2. Decrease the exponent by 1. Negative 1 minus 1 is negative 2. There you have it. A nice derivative. It's not written nicely, and I know I'm going to be plugging numbers into this, so I don't really want that x to the negative 2. So I rewrote it at the end like that. This right here is a nice derivative function that's real easy to plug in numbers. The only thing I have to plug in is that x squared. This is the derivative function. This will now find the slope of the tangent line at any point that I could ever hope for. That's the beauty of the derivative. So step 1 is done. Take the derivative. I use the split method. Can't always do it. Sometimes you can't avoid quotient rule. This time I could. Step 2 in our process is now let's find the slope of the tangent line. Well, that's what the derivative function's for. Take your y prime and plug 2 into it because it said when x equals 2. So I did that. You have 3 over 2 plus 2 over 4. Right? Because 2 squared is 4. And then I had common denominators. That's really just 3 halves plus 1 half. 3 halves plus 1 half is just 2. Okay? Or 4 over 2 if you really like. Or 8 over 4, but it's 2. That's the tangent slope. That's going to be good for my tangent line equation. But I know I'm also going to be writing a normal line equation, so I might as well right now find the normal slope. And what do we say? The normal line is perpendicular to the tangent. So the slopes are opposite reciprocals. So take that 2. This is really like 2 over 1. The opposite would be negative, and the reciprocal of 2 over 1 is 1 half. There we go. Normal slope is negative 1 half. Now everything else is just like what we learned yesterday. To find what the point is, because we want point slope forms, so we have the slope. Now we need the point. To find the point, just plug that 2 into your original function, y of 2. The original function's up here. So that'd be, if I plug 2 into that, 3 times 4, I had to get 12 minus 4 over 2 times 2 is 4. That's 8 divided by 4. 8 divided by 4 is 2. Wow, there's a lot of 2's in this problem. So the point that they're talking about, they told us they want to know what's going on at x equals 2. Well, now I know specifically that point on the curve is not just 2. It's 2 comma 2. Just Step 3 done. You know the point. Oops, let's use yellow. You know the point. And now you know both slopes, one for each equation, one for the tangent, one for the normal line. And if you know the point slope form, which is the best form to use for these problems, now just fill everything in where it belongs. Y minus 2 equals, let's see, this is the tangent slope. I found that is 2. Again, a lot of 2's in this problem. Careful not to get them messed up. That's the slope of the tangent line. Slope of the normal line is the exact same thing. Ladies and gentlemen, the point is not different. So it's still y minus 2 equals something x minus 2. The point is the exact same. But now the slope is the perpendicular slope, opposite reciprocal. So it's just a negative 1/2. And that is literally it. Finding the equation of a normal line to a function is not that much tougher than tangent line. In fact, it's the exact same process. The only extra thing is that you need to find the slope of the normal line, but that's just the opposite reciprocal of the tangent. Okay? If anything here confused you, don't worry. In class, we will recap this and redo it. Just make sure you try the one question homework. It's one question, and it looks just like this. Please get it done. Have a great one, guys. I'll see you later.